If you like these videos, please check out my full course at www.lsat.totaltestprep.net with tons of clearly explained actual LSAT questions written by someone who's mastered test and helped others master it, and an evaluation period where you only pay if you want to continue.
Alright, so in this video we're going to go into more detail with respect to conditional logic for the games. So, what is specific to conditional logic in the games section? Now, conditional logic appears frequently in the game section and it has some specific aspects to it which need to be recognized in order to completely understand it or to fully understand it. So, what is the role of conditional logic in games and how is it presented? And that's what we're going to cover in this video. So, in terms of the conditional logic in the games, the conditional logic primarily appears as the rules which constrain the relationships between elements. So the games are going to ask you to move certain elements around in particular ways, and a conditional statement or conditional statements will tell you how they can be moved. So for example, you might have a game like this one that says, it's very simply, it's dealing with toys and boxes. It says A, B, C, and D are toys that go into boxes 1 and 2, and then we can have a rule. And a simplified example of a rule would be if A is in box 1, then B has to go into box 2. And the way you would symbolize that is using your standard arrow. So A1, arrow B1. So if A is in 1, then B is in 1. Okay. Now, this is very important. In the course of doing the question, you may or may not activate the conditional rule. Okay, so that's very important. The first thing you got to think of when you're dealing with, when you have these conditional rules, or the first thing you have to recognize and understand when you're dealing with these conditional rules is that they're subject to activation, because it says if A is in 1, B is in 1. So for example, we've got a game here. We got our basic diagram 1 and 2. We've got the two columns for group 1 and for group 2. And then if the rule is activated, then the rule tells you what else has to be placed into the game, into the diagram. So if you know that you've got A in this spot, so you see that A is in 1, then because that rule says if A is in 1, then B is in 1, you also know that you have to put B in that spot as well. Now this is an example of it being activated and then the consequence being introduced, the consequence being placed in the game. So it says if A is in 1, then B is in 1. We know that A is in 1. And this, by the way, sometimes that'll happen on the basis of the answer choice that you're testing, the information the question gives you, etc. So additional information, you'll be given additional information, and on the basis of that, you'll have an element already placed into the diagram, and that might actually activate your conditional. And if it activates your conditional, then you know that whatever the conditional says is the consequence, or the necessary condition, or has to be true, in this case B being in 1, you got to put that into the diagram. But if it's not activated, then you don't know anything else. And this is where a lot of students tend to get tripped up on. So for example, you might be doing another question or another answer choice, and you're testing if A can go in 2, and then you see that A is in 2, and then you go through rules, and that first rule says if A is in 1, then B is in 1. And a lot of times students will put the B in 2 because they're like, well, if A is in 1 and B is in 1, A is in 2, that means that B's got in 2. No, you actually have no idea what else can be the case, because remember, this is the basic fundamental aspect of conditional reasoning. It tells you that if the sufficient is true, the necessary is true. But if the sufficient's not true, we still don't know. B could be in 1. B might be in 1. B might be in 2. It depends on other things. The point is that this diagram on the right, where we put A1 under 2, does not activate that rule. So you can't does not activate the conditional rule. So you can't put any additional information from that rule, in this case the B is in 1 or whatever it might be, into the diagram. And sometimes students are like, well, doesn't this violate the rule because A is not in 1? No. Remember, A does not have to go in 1. That's not what the rule says. It doesn't say that A is in 1 and B is in 1. That's not what conditional rules mean. What conditional rules mean, there's an if there. You got to remember it. They mean that what these rules say is that if A is in 1, then B is in 1. So if A is not in 1, we have no idea. Okay? And that's what that second diagram represents. You can have A in 2, and that doesn't tell you anything about what has to be next, because our rule only deals with what happens if A is in 1. Okay, so that's very important. And I can't stress this enough because a lot of students get this wrong. conditional rules are subject to activation. Activation means that the sufficient part is true. If it's true, then the necessary part is true. If the sufficient part is not true, we don't know. Okay. And also you want to pay attention to the contrapositive. So the contrapositive here is if B is not in 1, then A is not in 1. Remember, the contrapositive is just flip and negates. The logic, once again, is if you don't have the necessary condition, there's no way you could have had the sufficient, because the sufficient leads automatically to the necessary. So you just flip and negate. And we've got a rule here that says if B is not in 1, then A is not in 1. And if the negative of the necessary is activated, then the negative of the sufficient has to be true. In other words, if this conditional rule is activated. So if we have a situation, so we've got our diagram, and if we've got B over in 2, we look up to our rule, and our rule says if B is not in 1, then A is not in 1. Well, that actually activates that rule, because according to what we just put in here, once again, maybe you're testing an answer choice or it's part of the question or whatever, but we know that B is in 2. We've put it in there. We're testing the choice. Choice says we got to put in B in 2. So we're testing the choice. We got B in there. Well, we look at the rule. We look at our rules. Our rule says if A is in box 1, then B has to go into box 2. The contrapositive of that is if B is not in 1, then A is not in 1. Well, we know that we got to put the A over in the second column. So this is the same thing. It's just that you're using the contrapositive. And when you encounter a conditional rule on the games, you always want to draw out the contrapositive, unless it's really complex and you'd have to sit and think and figure out how to draw it. But 99% of the time, they won't be. 99% of the time, you just flip and negate. So you always want to draw a contrapositive next to it, because it makes it easier to recognize if a situation that you've established or that has come up in the course of testing an answer choice, if that situation actually activates the contrapositive. If you didn't have it out there, you'd still might be able to recognize it. If you just looked at if A is in box 1, then B has to go into box 1, you see the B is in 2, you'd have to be like, oh, wait, hold on. But if A is in box 1, then B has to go into box 1. But since B is not in box 1, then A couldn't have been in box 1, so it's got to be in box 2. But you see that you're doing a lot of thinking. Whereas if you just have the contrapositive, boom, it's activated. B is not in 1, A is not in 1. So you put in the A and you go on to test the rest of the choice or whatever it might be. So that's why you want to use the contrapositive. Make sure that you always write it out. Now, conditional logic is actually expressed in several different ways. It's actually not as wide a range of expression as you'll encounter in the arguments, but there's going to be a couple of different ways in which it's expressed. So there's the standard if-then formulation, which we have here. If A is in box 1, then B has to go in box 1. It has several synonyms. So the order can be reversed, and you don't need both of the indicators. You don't need both if and they. You could also start with the then part in the beginning of the sentence. So for example, B has to go into box 1 if A is in box 1. Saying the same exact thing as our rule, if A is in box 1, then B has to go into box 1, but it's just expressed differently. Remember, as long as you have a conditional indicator, in this case we've got the if right over here, we've got if. So as long as you got if, the sequence of the conditions doesn't matter in the English sentence. It's the logical relationship, and the logical relationship is determined by words like if and then. So you can have a situation where the English sentence or the rule starts off with a necessary condition followed by if, then the sufficient condition. You could have synonyms for the indicator, so it doesn't necessarily have to be if and then. So you might have when or whenever. So when A is in box 1, then B has to go into box 1. Or whenever A is in box 1, then B has to go into box 1. That's another way of, that's just another synonym for if. So when you see that, you know that you're dealing with an if then statement. You're dealing with a synonym for if. For then, the ones you'll encounter most often are only and only if. Only if is a little confusing because it's got an if in there, but that's just something you'll have to deal with. Whenever you see only or whenever you see only if, you know that you're dealing with a necessary indicator. It's a synonym for then. So something like that might look like A is in box 1 only if B has to go into box 1. Still the same thing, if A1 then B1, but this is expressed using a synonym for then, using only if. There's other synonyms, by the way, for if and then, but these are the ones that come up in the games. We'll encounter the ones, or we'll go over the ones for the arguments when we get to our conditional logic arguments lesson later in the arguments lessons. But for these, really these are only synonyms you'll find for if and then. So when, whenever, only, and only if. There is an additional thing you have to keep in mind. Unless is a weird synonym. It's actually a strange, it's something we use in everyday life, but this is a little bit counterintuitive to how we use it, and so that's why it's a little bit weird. So, as I said, it's used differently than everyday English. And the way I want you to understand it is by translating into if not. So, unless means if not. Well, what does that mean? So, let's say you have a rule that says B has to go into box 1 unless A is in box 2. Well, whatever follows unless is the sufficient condition, but it needs to be negated. That's what I mean by if not. So you find unless, in this case, A is, you got B has to go into box 1 unless A is in box 2. So you find the unless, and then whatever follows it is the sufficient condition. So if you were drawing it out, you would put it to the left side of the arrow. So A is in box 2, arrow, B goes into box 1. So the other part of the sentence, B has to go into box 1, that stays the same. You don't have to worry about it. You don't change that. It's just what follows unless. Then you're like, oh, this is the sufficient condition, so I'll put it at the start of the arrow, because usually unless, actually, the way it's used in English and the way it's used in the test, it's usually going to be in the second half of the sentence. So you just put that, whatever follows, make sure that's what's connected to unless. You put that at the beginning or prior to the arrow, and you have to remember to negate it. Why is that? Well, that's just simply what unless means. Unless is the condition which is an exception. You can think of it that way. So if that does not happen, so it's the accepting condition. It's a condition that if it's true, it changes what the consequence is. But you don't have to. That's a little complex. You don't have to think about it there, because you can. Part of the reason I don't go into that, and part of the reason why I teach it this way, is because unless is actually used a little bit more, a little bit less strictly in everyday language. In everyday English, it's got a slightly broader meaning than it does in the test. So just to keep things simple, I tell students, whenever you see unless, replace it with an if not, meaning that whatever follows unless is the sufficient condition, and you put that at the beginning of the arrow, and you make sure that you negate it. Now, how do you negate it? Well, you find the main verb, and you negate that. So in this case, it's is in box 2. So B has to go into box 1 unless A is in box 2. So if not, A is in box 2. So if A is not in box 2, then B has to go into box 1. So you see what I did? I just replaced unless with if not. I reread the sentence. That way it was kind of awkward, but I reread it to set up the conditions. So instead of B has to go into box 1 unless A is in box 2, I'll first say B has to go into box 1 if not A is in box 2. And then I'll put that at the beginning of the sentence, and I'll phrase it a bit more normally in English. So instead of if not A is in box 2, I would say if A is not in box 2, then B has to go into box 1. So the first part stays the same. It's the necessary condition. And just for clarity's sake, you'll rephrase it as an if then. But the key thing to remember is that unless is a sufficient indicator. That means that it's if, but it's the negative of if. It's just a little bit weird. And the way to do that is you rephrase it as an if then, finding the main verb and negating that. And remember, the other part of the sentence stays the same. That stays the necessary condition. So these are the common ways that you'll encounter conditional logic on the test in terms of how it's going to be expressed. There's going to be a limited range of synonyms. It's really going to be when, whenever, only, if, and unless. They might be phrased a little bit differently in terms of the actual statement of the condition. So it's not necessarily going to be if then or sufficient followed by necessary, because in English you can express it in different ways. You could have necessary followed by sufficient. You could have, like I said, these synonyms or even some missing indicators. But the point is, it's going to be relatively straightforward, and it's going to be rules for telling you where to place something once it's been activated. Okay, so to quickly summarize, conditional logic appears in games as conditional statements, which tell you what happens in the game once the statement is activated. And the conditional statements will be expressed using if-then formulation and various common synonyms.